I just wanted to show a quick little video of one of the ways you can get the survey. I wanted to create a short little video to demonstrate one of the ways you can get the servo to work. So you can see on the left, there's the simulator, and it has the wiring going from the pins on the bottom. So many servos, or most that I'm familiar with, have 3 wires coming off of them, usually a brown or a black, a red, and a yellow. And those would correspond with the ground, 3 volt, right? So that's giving it power. And then the number 1 pin is what's getting the information for sort of how to turn the servo. And you can see a little representation of the small servo down here. On the right, you see the code, and this is just repeating forever. So this came from the, if we go down to advanced and go to pins, and this gets pretty complex. There's a lot in here. And we're not going to go into a lot of this, but this is where you could go as you get more complicated in what you want to do. And it's a little bit off screen here, but basically down at the bottom of this list, there is a set of functions that are for the servos. So we have a couple of those in our program, and you can change both the pin number. So we have it on pin 1 right now instead of pin 0. And then the 180, you recognize that as the starting degree. So if 0 is sort of north or at the top, right, 180 is down to the south or the bottom. And then if you look at the code, it goes from, it starts at 180, it waits, it then goes to 90, it waits, and then it repeats. So that's where you're seeing it. It starts here, it goes to 90, and back. So this is one of the approaches that you can use to utilize the servo. This is not very exciting, but this is just showing some basic functionality. Another way to get the servo functions to work. For this, we're going to explore extensions. And we haven't done much with this, but if you need extra functions, and it seems like something that other people have likely done, either using a different type of sensor, like a soil sensor maybe, or you could see on here even data logging. If it's something like that, you can come in here and search and see if somebody has basically figured it out. This is where you'll come if you have a breakout board or other functions that are tied to the sensor or the whatever thing is that you're trying to connect to the microbit. And for this one, if we search servo, you can see a number of servos that come up in this window. But for right now, we're just going to pick this one that says a microserver library. And what that does is, you might have noticed that in between radio and loops, it dropped a servos drawer. And in my experience, these are always things that you can do with the regular code, but oftentimes what they're doing is trying to make it simpler for you, where they're creating a block, let's say, or a set of blocks that might take quite a bit of code to accomplish, or sort of a complicated, process that when companies or people are creating these, it basically gives you some shortcuts. So now if we click on servos, you can see that it has set servo angle to this and continuous servo. There are a couple different types of servos, some that will go completely around in a circle, so 360 degrees. And sometimes that is sort of running continuously. And then others that will make a move, usually, let's say 180 degrees, and it sort of can go anywhere in that 180 degrees, but it's more of a, move, stop, and then if you want it to move again, you can do it that way. And those more simple servos are cheaper, and they might be used for something like opening a door or a flap or something like that on some little creation you have. So if we drag out the set servo angle to 90 and we put that in forever, what I think will happen is it shows you the configuration, the wiring configuration, okay, and then it shows the servo, the little sort of white indicator. With this extension, it appears that having the servo straight down is equivalent to having the angle set to 90. So with this, if we click in where that variable is, we can change it to 0 and see it probably should go to one side or the other when we do that. And if it doesn't seem to be responsive, one thing you can do is if you hit this sort of refresh here, okay, so that goes all the way to the left position, or sort of west direction at 0. So if that's 0 and down here is 90, we can assume or predict that this is going to be 180. So let's try that. And this one only goes to 180, right? So this is one of those servos that only has motion in that sort of half of a circle. And again, if we refresh, right, that goes to 180. So let's play with this a little bit. So what I want to try to do is we could have this servo associated with some sort of other function. So just to make it simple, what I was thinking is if we pick a random number and we make that random number between 0 and 180, then we can put that in here. But that's not that exciting. It'll just, you know, what you're seeing right now is it's picking frequently it's picking random numbers, and that's why it's jittering all over the place. So let's throw a pause in there. And sorry, let's do this and see if that calms it down a little bit. So it makes it actually a little bit less jittery, but let's do it even more. So let's do it about a half a second. So just to show that you could have that servo angle set to either a specific value that's tied to something that you're doing. Like I said, you could have it open a flap if somebody answers a question correctly or something like that. You could have it where that servo motor is representative of, you know, some sort of number. So the brighter the light is that the microbit is sensing, then it's changing that. So let's just play with that for a second. If we pick the light level here and we get rid of that. Now I know the light level goes above 180, but if we set that angle to the light level, and up here in the simulator we sort of play with that light level, right? It maxes out when it gets very bright, but as it gets less bright, you can see that it sort of tracks the angle. And so again, perhaps you could use that to tilt something toward the sun, or to do something like that. So very simple function, but again, we got this through going into the extensions, searching for servos, adding that extension in, and then that gave us a whole variety of options here. One thing I'll say is sometimes it might not be clear which extension might be better. I don't think you can really hurt anything. So sometimes it might be worth searching, adding one or two extensions in, and then seeing what they do and seeing which one might best serve your needs. There might not be the right extension, but it's worth at least trying it out to see. Just wanted to show a little bit of how you might wire your servo to test it out. So we have the servo that we sent you here. We also have a little packet here of the little connectors, the sort of arms. And to show the motion, it's easier to put one of those arms on, but I will not screw it on. So I will put it on like so, and it can snap on. And like that. And then you can see that this connector has 3 wires, but it does not, have any tips or anything that you could connect to the microbit pins easily. So one option would be you could cut these wires and strip them so that you have wire ends. But we included some other wires for you to work with, and they should work to just plug right in. And I usually, if I can, try to match the colors to just make it easier to follow. They should plug right in here. And so I've got a yellow and a red and then a brown. So it's brown to brown. So in almost every electronic situation, the red should be going to the voltage, and the brown or black to the ground. And then in this case, the yellow is going to go to the pin. And so that might be your connection with the sort of available wire tips on the other end. And those wires we're going to connect to the alligator clips. And there's surely other ways to do this, but for this, we're going to connect to the alligator clips. And the other end of these alligator clips that I'll show you in a second are connected to the microbit itself. And so we have those connected. Like I said, we have this servo, and so I have the microbit connected to a battery pack and then to a servo here. And the code is supposed to work such that when the light level changes, if I press button A, it will change the servo position based on the light level reading. So I'll start it here, move this around so you can see, and I'll start here and hit A, and it gives basically the same position. If I turn the microbit toward the light, it doesn't do anything because it's not given enough power. So we have the servo here, and I'll talk in a minute about why we're only seeing the servo, but based on the code, if I hit button A, it will, so the starting position is, based on this, the starting position of the servo is at 90, and then when I hit button A, it will take the reading of the light sensor in the microbit and move the arm to that position. I'm going to hit A now. Like I said, I'm going to hit A now. And it moves to that position. So I'm going to, you can't see this, it's off screen, but I'm going to cover up the light meter and hit A again. And it moves slightly, and then it returns to 90. So it moves slightly based on the reading, and then it might return to 90 over time. So the reason I switched from the servo we sent you to this servo is that the servos that we sent you are not weak enough to be moved by the microbit. So see how it says micro servo 9G SG90. So this model it requires a little bit too much voltage to move to various positions. So if you connect this to the microbit the way I showed you, you will hear it sort of struggling to move. It might even chatter a little bit. this servo is from a different company, and it is of the right voltage to move, and so that's why I was trying it exact same wiring, but it will move in response to the lower voltage and amperage that the microbit can put out. So usually, this is why when you're working with servos, you would have the microbit attached to some sort of breakout board, which we'll talk about a little bit more soon. Or there's also a way to connect it where the servo itself is connected to sort of an external battery pack, and that gives more power, or the power that's needed to move the servo. So if you face this, this might be one of the challenges that is happening.